Hello, I'm Rafał, and I'm speaking to you from Poland, from Krakow, and my talk is titled "Build Your Operator with the Right Tool." But first, a few words about myself. So I'm an integration team lead at Hazelcast. Before I worked at Google and CERN. I'm also an author of the book Continuous Delivery with Docker and Jenkins. And from time to time, I do conference speaking and trainings, but on a daily basis, I'm a developer. A few words about Hazelcast. Hazelcast is a distributed company, and it's distributed in two meanings. First meaning is we produce distributed software, and the second meaning is that we all work remotely. We have employees all over the world, and it was forever this way. We work from all over the world. Our agenda for this talk is pretty simple. So there will be a short introduction to set up the context, and then I will walk through possible methods to create an operator. I will start with the most popular operator SDK, and then I will walk through some other solutions like some other frameworks to end up with the implementing operator completely from scratch in any programming language you want. While I'll be describing the solution, I will be always giving some comments and some pros and cons of each solution. So let's get started. The intro for this is you want to build a Kubernetes operator. And now is which tool to choose? Should you go mainstream with Operator SDK with Helm, Ansible, or Go, or should you start from scratch using some other languages? So Kubernetes Operator, in general, it is an application that watches a custom Kubernetes resource and performs some operations. So this definition is very generic because operators themselves can do a great variety of things. So to make it more digestible, let's focus on one example that we will use throughout this talk. This example will be Hazelcast Operator used to create and scale Hazelcast cluster. So let's imagine that as a user of the operator, you would like to specify the following custom resource. The only parameter, so we have a custom resource called Hazelcast. We give it a name, and the only parameter that you can specify is the cluster size, which should imply how many pods of Hazelcast will be created in the cluster. Now, you as a user would like to execute this command and have Hazelcast cluster ready. That's it. And so this will be a diagram. You modify as a user, you modify Hazelcast resource, then our Hazelcast operator application watches the Hazelcast resource and interacts with Kubernetes API to create or update a deployment with the given number of Hazelcast pod replicas. So this example is pretty simple, but in real life, a change in Hazelcast YAML resource could result in more complex operations, like, for example, cleaning data in the Hazelcast cluster or upgrading the Hazelcast version or sending metrics logs or setting up some geo-replication. There is no limit here. The point is that an operator observes the resource and it performs any operation you want. Since you can write operator since operator is just any application which is Dockerized, run in Kubernetes, technically, you can write it in any programming language or framework. What's more, Kubernetes exposes a REST API, so you can really use any language to watch for Kubernetes events and to interact with Kubernetes cluster. Now, like on this diagram, on this slide, you can see I grouped it in some ideas. So you can use Operator SDK, some frameworks, or bare programming languages. Now, no matter which solution you choose, there are some steps for the operators that are the same. So no matter how you implement your operator, you will always first need to implement as a step one. You will always start from implementing the operator logic. Then you will Dockerize your operator and push it into Docker registry. Then you will create custom resource definition, which defines how your custom resource should look like. And then you will need to create some role and role bindings, which will decide on the permissions for your operator. Then you will deploy this operator in a form of a pod or a deployment. And finally, you will be able to apply your custom resource, and operator will watch it and do something about it. So if we look at the steps, only the step 1 is different for different operators. All the other steps you need to do anyway. That is why we will, while I'll be describing operators, I will focus on the point 1, and for the points 2 to 6, I will just give an example how to execute it, but it will always be the same. Okay, with this introduction in mind, we can go to the meritum and to describe the possibilities for building operators. So the first one is using operator SDK with Helm. Helm is a package manager for Kubernetes. It allows to create a set of templated Kubernetes configurations, package them into a Helm chart, and then render using parameters defined in values YAML. Helm is super simple because your knowledge is just, what you need to know to use Helm is actually just to define Kubernetes configurations. That's it. So in our example, to create Helm-based operator, we need first to create Helm chart. And out of this Helm chart, we will generate the operator. So to create a Helm chart, we execute Helm create chart, and then we need to define templated Kubernetes configurations in chart templates folder. And our chart values YAML are the parameters. So if you look at this sample, you can already see it's super simple because it's just Kubernetes configuration. So it's something we know. That is very simple. If you would like to generate an operator out of this Helm chart, you need to execute operator SDK init and operator SDK create. That's it. Your operator is created. And then to build, install, and use the operator, we have these common steps we already mentioned. So to see how it looks like in practice, let me show you. I have configured I have connection to a Kubernetes cluster, and this is a repository I will share at the end of this presentation, where you have all these examples if you want to execute it by yourself. But if we want to see the Helm example, so here are the steps how to create an operator. I already have it created here. So our Helm chart is here. Here is the chart. In the templates, we have just one deployment configuration, and this is exactly what we've seen on the slide. So it's basic Kubernetes configuration with templated value size. Our parameters for the Helm chart are located in values YAML, and that is just the size of the cluster. Now to generate operator are these commands I already mentioned. So you would need to execute these commands, and then we can build our operator with this operator Helm. Can build it in Docker and push it to Docker registry. Then we can, to create Hazelcast CRD, operator SDK provides a make file. So just executing make install will apply Hazelcast CRD. Then we deploy an operator. Watch what operator SDK does with make deploy. It will create a deployment with one operator pod. So let's do it. And it automatically assigns role and role bindings, so you don't have to think about it. And the operator should be already deployed, so we can check the logs. It's already, we can see that something is already running. So let's observe the logs of the operator. And so here are the logs, and then we apply our configuration. So this is what the end user does. Now apply our configuration. By the way, it looks like this: config samples. So this is our configuration. It was also generated from the values of the Helm chart. And if we apply this configuration, we should see that Hazelcast. We should see, yeah, there are some logs in our operator pod, and we should see that that Hazelcast pod was created by the operator. Now, if we would like to scale it up to, let's say, 3, we apply this configuration again, and and you see that Helm-based operator reacted, and we should see 3 pods running. By the way, if you are interested in the Hazelcast log itself, you can see that that they should actually form one Hazelcast cluster, so Hazelcast members discover themselves automatically. So that was pretty simple. If you would like to clean it up, let's just do it, and that's it. So this was the simplest operator example. Now you may have seen like operator capability levels. So this is a slide from the operator SDK, and what we can see on the slide is that Helm-based operator is limited. So you will not implement anything you want with this operator, because Helm itself is limited. It's just a declarative Kubernetes configuration templated. So you will not do any like very difficult operation like I don't know, scaling or sending some metrics, log alerts, or I don't know, some sending requests to some external service. Helm is limited, but it's also very simple. So a few comments about the operator SDK Helm approach. So operator implementation is declarative and therefore simple. It requires no more knowledge than the standard Kubernetes configuration. And if you already have a Helm chart for your software, then creating an operator requires no more work at all. That's what we did actually in Hazelcast. We already had pretty well developed Helm chart, so we just generated an operator. Your operator functionality is limited by the features available in Helm. And one other good thing is that all operator manifest configurations files, all the CRD, role bindings, they are automatically generated. So we don't have to think about maintaining them, etc. So that's the easy part. Okay, let's move on. And the second possibility you have when you would like to implement an operator is using operator SDK with Ansible. So Ansible is a very powerful tool for IT automation, and its nature is declarative, and thanks to a number of plugins, you can write simple YAML files to perform very complex DevOps tasks. And Ansible has a plugin called Community Kubernetes Couchbase plugin, and this plugin is dedicated to interact with Kubernetes API. So if you would like to create an operator, let's do the same example. We would like to create Hazelcast operator using Ansible. We first need to scaffold the project. So we execute operator SDK init, operator SDK create API, and the project is scaffolded. Then we need to implement our logic, and we can do it in roles Hazelcast task main YAML. This YAML file is Ansible task YAML. So, but it looks pretty similar to the one you've seen before, because it's actually embeds Kubernetes configuration. However, the significant difference is that to the Helm-based solution is now that these files are interpreted by the community Kubernetes plugin and then passed to the Kubernetes API. While the Helm configuration was just direct Kubernetes configuration. So that's all we had to implement to have our operator. And then if we would like to build it and so on, it's you just execute the same steps we've already seen. If you are interested in how it works in practice, I will share the link to this repo so you can execute these commands by yourself. One thing is, if we come back to this slide from Operator SDK, you see Helm was limited, but in Ansible you can do almost anything you want, because Ansible is declarative, but it's a very powerful tool. It has a lot of plugins. You can actually, it's very, very internally, it's a complex tool. That is why you are not limited to the basic install operator. A few comments about the Operator SDK Ansible approach. So Ansible allows implementing operator in a declarative form, which is concise and human readable. And Ansible operator is similar to the pure Kubernetes configuration, but actually it's executed by the community Kubernetes plugin. And Ansible is a very powerful tool, so it covers all capability levels. And similar to the Helm-based operator, all configuration files manifest, they are automatically generated, which is good for you. That's about Ansible. The next thing we'll look into is Operator SDK with Go. So this is the third solution you have when you would like to implement your own operator. So Go is a general purpose programming language, so you can technically write any operator logic you could ever imagine. And what's more, the Kubernetes environment itself, it's written in Go. So the Kubernetes client library, it's kind of native. It's the best of its kind. And also, like the people use Go for the performance. So this is the one of the reasons people use in general Go. So then you use it in your operator. Also, you can use it for the performance reason. If you use Operator SDK, again, you can first scaffold the project and only later write the code. So again, you use Operator SDK init, you use Operator SDK create API. It scaffolds the Go projects for you. So you don't have to write all this boilerplate code. Then you need to implement the logic. And the logic is in the Go language, obviously. There was too much code to put on the slide. So you already see that it's way more complex than using declarative form from Helm, for example. But if you look at this logic here, you really like a procedural, like a imperative code. So you need to check for the deployments of the Hazelcast kind, then check, okay, if the deployment was not found, then create the deployment. If it was fine, then update the size. So you really write the logic, which is obviously way more difficult and complex. One thing that you can note on this slide is that the first comment just above the reconcile method. So the first comment, this kube builder, it's actually the comment that is later transformed by Operator SDK into row and row bindings files. So it's generated. So it's a very, very nice feature. One other good thing about the Go operator is that you remember, like before, like we defined our deployment, our Kubernetes configuration, we defined it in a YAML, in a Kubernetes YAML file. But in Go, you have a very nice way of defining this in a native Go language. So it's actually it looks very good. And what the code snippet you see on the right side is our structure. This is our your custom resource will be validated against this structure. So we have one parameter size. So in this Hazelcast spec, we have one parameter size. Now, if we implement this to build it, run it, install it, like use it, it's the same as what we've seen. So this is exactly the same. If you would like to look at the code of the Go, it's actually pretty interesting, because if we look at the Go code, we can see that the logic is implemented in the controllers, and you already see like this file there's a lot of things here. I mean, this is a long file, so you have to think about, like, if deployment was not found, we create a new deployment. So we create it here. We have to write all the error handling. But if the deployment was found, then we need to update its size, and we need to update the deployment. So we need to really like write the imperative code for this. So even for such a simple operator, you write quite a lot of code. But the good thing is that you are not limited by anything, because in Go you can write really anything you want. So a few comments about operator SDK Go approach. So you implement your operator in an imperative code, which requires more work and caution. Go language is very well integrated with Kubernetes, so this is a good thing. Yeah, you will not find a language which is better integrated than Go. It's a general purpose language, so there is no limits on the functionality it provides. And there is some scaffolding, boilerplate code, manifest generation. So operator SDK gives you some tooling for free. Okay, we covered the mainstream. The mainstream is operator SDK. But you may want some other options. So other options other option is to use some operator framework. Some operator framework different than operator SDK. So if you look on the internet, there are a few operator frameworks. You can just Google them. Obviously, operator SDK is by far the most popular, but you can find some others. This is what I found. There is a COP operator framework for Python. There is one for C#. There is one for Node.js. There is one for Java. There is one for Rust. You can probably find even more. But now, before starting to use any of this framework, first thing we can check to even agree that we can use some framework is to see how popular it is. So one way of checking the popularity is to check the GitHub stars. So if you look at the GitHub stars, you are probably better not using C# operator SDK, Node.js the same, maybe Java, maybe Rust. This Python one looks the best actually. And if we look deeper into this Python framework, we can see that it was actually moved from some other GitHub repository which had almost 1,000 stars. So it's like a good candidate. If we look even deeper, we can see that it was developed inside Zalando. So there is some company, big company implementing this, using this. So this looks like a good idea to try with this framework. So let's try to implement Hazelcast Operator using this COP framework. So this time there is no scaffolding, there is no boilerplate code generation. So implementing configuration manifest file, you need to do it on your own. So you need to implement the Docker file, Hazelcast CRD, role, or binding operator deployment and the resource itself by yourself. You have to implement and maintain it, obviously. Then if you have it, then finally you can implement the operator logic in a Python file. And let's look how this operator logic looks like in a Python way. So these are the two methods we need to write to provide the functionality of creating a deployment of Hazelcast. You can see on the right side that creating deployment, embedding the Kubernetes configuration inside Python looks quite good actually as the code. And on the left side, we have the code to create a deployment. And Python itself is quite a concise language. And thanks to the Python decorators like this conf on create, it looks pretty good, I must say. It's an imperative code, but you don't have to write a lot of lines of code to do what you want. So in this function, obviously, we create deployment from the specification, and then we need to use a Kubernetes client to create the deployment and close the session. As simple as that. Then to build, install, and use the operator, we basically need to follow the same steps we already did. So if you'd like to look at the code, how it looks like, so it will be the same what we've seen on the slide. So we have our Python project. Now we need to write the Docker file and all this CRD, etc. on our own because it's not generated by this framework. And the same with role bindings, role, etc. And the logic is here. So we had like this create a function for creating and a function for updating, a separate function for updating, and that's it. So it's pretty well. I actually, the code itself, I actually like it more than the code in Go. Again, if you'd like to execute it by yourself, I will share the slides and share all the presentation details with you. A short summary. So a few comments about operator, if used in general, operator framework. So operator framework in general are less developed and popular than operator SDK. So you will have to implement more things and maybe contribute to some operator framework. So there's no project scaffolding or boilerplate code generation. However, like there is, again, like with the Go language, there is no limits on functionality because you use a general purpose language. So you can write any code you want. You would like to call an external service, no problem with that. And each Kubernetes client for any language, you better first check how the Kubernetes client itself is developed, because you don't want to implement some REST calls by yourself, because so you need a good Kubernetes client for your programming language. For Python, I guess it's fine. For most, like for Java, there is a good Kubernetes client. So for most mainstream programming languages, there is a good Kubernetes client. And the last point in our agenda is to use a bare programming language, like any language you want, because as mentioned, like operators are nothing more than a Dockerized application. So you can write it in any programming language you want, Dockerize it, and this is your operator. So here I listed some of the popular languages that people try to write operator in them, but you can be an innovator. You can write it even in really any programming language. For example, to give an example, I found a very good blog post which I will share at the end of this presentation about writing an operator in Java with Quarkus. And this is like very tempting approach because Java is very popular and it's very enterprise language. And the Quarkus lets you use GraalVM and make a Docker native image, which means that it will be very fast. So you can write some very, very good operator. Now, if you'd like to create the operator, what we'll do is you have to, again, like the same with the operator framework with Python, you need to implement all this boilerplate file, the manifest file, the configuration files on your own. So there will be no one implementing this for you. And when you have these files, then you can implement Java classes with the operator logic. How it looks like in Java. So this is the main, this part is the main logic of the operator. So we take some old deployments, we filter them, then we check if they are not empty. If they are not empty, then we create the deployment. If we found something, then we set the size of the deployment. So it's again like with the Go or Python, it's imperative. So you need to cover like each of these things, cover each errors. You are on your own here. Now, since this is just part of the code, since this is Java, you will have to actually. This is I couldn't find smaller font, so even though it's already not readable, yeah, there are a few. There is one more class here. There are one more class here. So there's a lot of code to write on boilerplate and boilerplate. It's like it's the combination of Java and using no operator framework. So it must result in a lot of code to write and a lot of code to maintain. So Java is verbose. The Kubernetes client for Java is verbose. So really a lot of code to write. On the other hand, if you're already implementing a lot of stuff in Java, you are used to this boilerplate and it may not look that bad to you. Then to build it, we have two options. We can either build like standard Java Docker image, or we can use this Quarkus extension and build like a native Docker image, which will run very fast and which will be good in terms of resources. And then to push, install, and use, we execute the same steps as before. If you'd like to see like all the Java code, then I have it here. I already showed the slide. I will not walk through all the code because that could be boring, but there's just a lot of boilerplate. This class is just defining the producers for the Quarkus framework. This is some other class for installing this is the main logic actually, and like 4 classes with the boilerplate. So yeah, that's Java. So if you decide to use like a bare programming language, no matter Java or any other language, then it always means writing more code. You'd better first check if your language has a good client library, because that will you don't want to implement both like all the operator logic and then all the Kubernetes client library, because then you're just reinventing the wheel. You write everything you want, so there's no limits on the functionality. And I see like I don't think bare programming language is a good approach, but I see one valid reason for this is if you are already using like single programming language in your organization, and it's just easier for you to maintain. Then it may be tempting, this one use case. So it was the last way of creating an operator. So as a short summary, you might ask like a question like, which tool should I use for my operator? So you can look at the code snippets from this presentation and from the GitHub repo I will share, and just choose the right one for you. However, that is just the part of the story. Because let me give you an example. I am a Java developer. So for me, using pure Java would be actually the simplest solution out of this. However, I would never write an operator in Java. Why? Because most developers don't write operators in Java. So I would be alone in it. I would be like alone with the bugs, alone with new features, alone with my questions or Stack Overflow. And programming is a collaborative work. So the question for the end of this presentation is like, what operator tool do others use? Because I want to use something that is like common in the community. And to check what is common, I looked at the Operator Hub, which is a repository for operators, and I checked the most popular operators. So I first looked at the Prometheus. What does it use? Go. CockroachDB is very popular. What does it use? Operator SDK with Helm. Then Datadog. What does it use? Go. Snyk, Helm, Jenkins, Go, Redis, Go. So you already see like a trend, but I went even deeper and checked all the stats, so how it looks like. And this is the chart of all the operators in Operator Hub. So there are in total like 159 operators, and here are the stats. So we see that the Go-based operators are by far the most popular. You may find this data slightly biased because the operators published at Docker Hub are only those operators that are built and distributed for others, like the tools. So you won't find any internal operators there. But still, if you decide to develop an operator in Go, you're in a very good company. So as the last thing for this presentation, I would like to give you a few hints how still to decide on the operator and on the tool to use for the operator. So my hint number one would be, if you already have a Helm chart for your software and you don't need any complex capability levels, then use Operator SDK with Helm. Hint number two, if you want to create an operator quickly and you don't need any complex capability levels, use Operator SDK with Helm, because that's the simplest, the fastest way you can do. Hint number three, if you want complex features or be flexible about future improvements, then use Operator SDK with Go. Now, hint number four, if you want to keep a single programming language in your organization, then if there is a popular operator framework exists and you want to contribute to it, then use some operator framework. However, if there is no popular operator framework, then use bare programming language. It's still okay. Hint number five, if none of the mentioned, then do what others do, so implement your operator in Go language. And as the last slide, I would like to share with you some resources. So the first one is the link to the code for this presentation if you would like to build and run these operators on your own. Second one is the the link to the Operator SDK. Third one is a very good blog post explaining step by step how to build an operator with Java and Quarkus. And the last one is a link to this Python operator framework, which is really, really well written framework. So you may consider using this. And with this last slide, I would like to thank you for listening. It was a pleasure to speaking at the Operator Con. Let me check now if there are. Let me check if there are any questions. Let me. I don't. Okay, I see some questions, but they're not filtered. So I will maybe let's do it this way. I will answer these questions on the chat here under the session. So that would be just simpler to operate. So thanks again for listening.